Students, geometry back, welcome back, geometry students. Today's notes are titled 9-4, Special Right Triangles, 45, 45, 90. All right, and what we involve here are triangles, are right triangles, that have a special case to them always, and we can always do the same thing with them. Let's get started. The type of triangle that we have, if we want to draw it out together, it's a right triangle. And in that right triangle, both the other angles, that's not the right angle, will be 45 degrees. Hence the name 45, 45, 90. Okay? And on this, if my angles are both 45 degrees, that's going to mean that both of these sides are congruent. So this actually gets us, the special triangle that we have, is an isosceles right triangle. So the isosceles right triangle looks like this, and the relationship that exists within this right triangle, both these sides are going to be the same. So let me label those as x. Each one will be the same. Then I can always find the hypotenuse because it'll be that x then multiplied by square root of 2 every single time. So let's summarize that. If I have a 45, 45, 90 triangle, their sides are always x, x, x square root 2. And I can write this down. You're going to find me writing this down every single time I solve a special right 45, 45, 90. Before I get there, though, it's important to understand this square root of 2, and I need to do some things with it. So I'm going to go over here to my other side of my foldable and talk about multiplying and dividing radicals. Okay, we should understand how to simplify radicals. We've done that several times, but how to multiply and divide them. So things such as, if I have radical 2 times radical 3, and I start calling these radicals, not square roots. They are square roots, but it's a lot easier to say radicals. Radical 2 times radical 3, okay? All you have to do is multiply what's underneath of each radical sign. You'll hear it called the radicand. So radical 2 times radical 3 is just simply radical 6. There it is. All right? If I have 5 radical 2's and multiply that times another radical 2, okay, I got that 5 outside, and there's nothing else to multiply it by, so it goes by itself, and then radical 2 times radical 2, multiply what's inside, is radical 4. That's not it, because I know radical 4 is 2 by itself. So this is like 5 times 2, so I get 10. So 5 radical 2 times radical 2, the answer is 10. All right, what about dividing radicals? If I have 8 divided by radical 2, okay, what I do with this is kind of a special case. So I'm going to write out what I do. The simplest way to talk about it is I'm going to divide the number on top, the numerator, divide the numerator by 2, because that's what the number inside of the radical, divide by 2, and then multiply by the radical 2. So if we do that together, if I have 8 divided by 2, that gets me 4, and then multiply the number times the radical 2. Okay, so there's a simplified version, or a simplified answer of 8 divided by radical 2. There's 4 radical 2's. Okay, what if I have 12 divided by radical 3? Well, I have to divide by the number inside the radical, and then multiply the radical there. So for this, I'm going to divide by 3, and then multiply by radical 3. So if I have 12 divided by 3, that gets me 4, and then multiply the radical 3 with it, so 12 divided by radical 3 is radical 4. So there's kind of a brief outline. We're going to do that several times. All right? Example 1 inside of our foldable. Example 1, if I have a right triangle, and it's a 45, 45, 90 right triangle, all right, and all I know is that one side is 3. Now here's the beauty of these special right triangles. Whereas with Pythagorean theorem I have to know 2 sides, I only need to know one side with these to find the other 2 sides. Okay? Anytime I solve these out, I always write out 45, 45, 90 is summarized by x, x, x square root of 2. The side across from 45 is represented by x, the side across from 45 is x, and the side across from 90 is represented by x square root of 2. Okay? So the important thing is, the key here is to find out what's the value of the x. Across my 45 is 3. So in place of this goes the 3. That means that x is equal to 3. Anywhere in this then, I just put that 3 in place of the x. So this one will also be 3. And here across from 90, the x is 3, so I've got 3 square root of 2. So back onto my triangle, across from the 45 is my other x, so that was 3. And across from the 90, the hypotenuse is 3 radical 2. And that's it. Now, you will find with the Pythagorean theorem, if you do 3 squared plus 3 squared equals c squared, you're going to get 3 radical 2 as your answer. So the shortcut is just to use the pattern, the 45, 45, 90 pattern. Let's do another one. Example 2. I have a right triangle, and this time the only thing that's marked is that both the angles are congruent. If that's the case, then I know it's a 45, 45, 90 triangle. The hypotenuse is 10. So I list it out. 45, 45, 90 is x, x, x radical 2. In this case, across from my right angle is the 90-degree angle. Across from 90 is 10. So 10 is across from 90. Okay. So I need to solve out what x is. This one doesn't jump out to us as quickly, but I can write over here that the x square root of 2 equals 10. It's represented by 10. How am I going to solve for x? I need to get x by itself. Well, I divide by radical 2 on both sides. Now, so radical 2 divided by radical 2 simplifies just to 1, so it's gone. So x equals 10 divided by radical 2. And as I did previously, to divide by radical 2, I divide by 2 and then multiply by radical 2. So 10 divided by 2 is 5, and 5 times that radical 2 is my answer. So the value of x is 5 radical 2. So fill it in back here on our chart, our table. Okay? And then I can put it on the triangles. The side across from the 45 is 5 radical 2. The side across from the other 45 is right here, so 5 radical 2 as well. And again, that's all there is to it. One more example, example 3. This one is going to give me some words. So if it says the perimeter of a square is 48 centimeters. Okay? Find the length of the diagonal. Yes, I want you to write this down. Write out the words. All right, let's draw a picture of this. If I have a square, and it says the perimeter is 48 centimeters. Well, the perimeter is the distance all the way around, so I can divide 48 by 4, and I get 12 centimeters on each side. Okay? And the question is asking me to find the length of the diagonal. When I draw the diagonal in, I have all right angles originally, and then whenever I draw a diagonal in a square, it actually bisects the angles. It cuts them in half. So these become 45 and 45. There's my 45, 45, 90 triangle just right here. I can disregard the top half. So let's write down 45, 45, 90 is x, x, x square root 2. And then what's represented by across from the 45 is 12. Across from the 45 is 12 again, because it's the same. And therefore, across the 90 will just simply be 12 square root 2. So my diagonal is 12 square root 2 centimeters. Okay? There's our practice with 45, 45, 90 triangles. Make sure you fill out the WSQ. Bring your notes to class, and we can get some more practice in. Thanks, guys. Have a great day.